Rrb. So today I'm going to discuss about synchronous machines. Basically, what do you mean by synchronous? What do you mean by motor? Actually, before going to the discussion, what do you mean by motor? See, an electrical motor is a device which will convert the electrical energy into the mechanical energy. See, motors can operate on AC or DC. Also single phase as well as three phase supply. In fact, AC supply is very commonly available as AC motors are very popularly used in practice. AC motors are mostly three phase motors. I think except small motors used in many types of equipments in homes, offices and also shops, etc. So mainly AC motors can be classified into two major categories. One is synchronous motors and also another one is asynchronous motors. Synchronous and asynchronous motors. See, today I'm going to discuss about the synchronous motor. See, what is a synchronous motor? See, synchronous means the motor which converts electrical power into mechanical work and always work at the synchronous speed. See, and always work at a synchronous speed. It's called synchronous motor. See, in this, the speed is constant irrespective of load. Understand? Irrespective of load, the speed will be always constant. And this is a doubly excited machine because the field winding is excited from a separate DC source. Okay. And earlier I said that asynchronous motors. Asynchronous motors means it does not operate at a synchronous speed and the speed varies with the load. That is mean by asynchronous or induction motor. Okay. Before going to the discussion, we will let you know about what is mean by synchronous. Okay. Coming to the construction part, stator. Stator is a stationary part and rotor is a rotating part. In this we use excitation system. We excite stator and rotor separately. Okay. What is mean by excitation? When we supply 3-phase AC supply to stator and also we supply DC supply to the rotor. Here the currents are sinusoidal in nature. What do you mean by sinusoidal means the positive off cycle in a particular interval of time. Let me show you one diagram. See, this is sinusoidal in nature. See, this is the positive off cycle and this is the negative off cycle, and also the positive off cycle at a particular interval of time and the second negative cycle at a particular interval of time will both make one complete cycle of the wave. Because of this positive and negative off cycles, positive and negative off cycles. See, coming to the working principle of the synchronous motor. When a 3-phase AC supply is fed to the 3-phase stator windings, a resultant magnetic field is produced. That is, RMF is produced. So this will rotate at a synchronous speed. The NS is produced on the stator. See, this is the NS is produced on the stator. Let the two poles having N1, S1, N2, S2. Okay, See, this one is a one pole, N1 is a one pole and the S1 is also one pole. This is subject to stator winding, okay, and this is the rotor, and this is N2 and S2, and this is subject to the rotor. Okay, these poles. Okay, coming to the point. Okay, when consider an instant when the two stator poles are at the positions A and B respectively. See, two stator poles A and B respectively, and this is the figure. Okay, the arbitrary positions of the rotor of N2 and S2 are shown. Okay, at this instant the rotor is stationary. See, this rotor is stationary. Okay, unlike poles will try to attract each other. Due to the rotor will subjected to the torque in anti-clockwise direction, but after off a period of cycle, the stator poles, see, first off cycle, next off cycle, but after off period of cycle, the stator poles interchange the positions. Interchange, see, N2, S1, the stator poles interchange. See here N1 and here S1 during the first half cycle. This is during the second half cycle. The poles got reversed. This will be stationary only, but these poles are changing. Due to the interchange of these positions of the stator during the period, because of inertia, the rotor hardly moves from this position. Hardly moves, not completely, but in other words, we can say about tilt, just only tilt. It does not completely rotate. It only tilt. At this instant, due to the unlike poles, see S1 and 2, these are two types of poles. These unlike poles trying to attract each other, and the rotor will be subjected to a torque in the clockwise direction, and this will rotate in the clockwise direction. Here also, in these both the conditions, the rotor does not completely rotate either in anti-clockwise or here in clockwise. In both the cases, the rotor try to tilt, just move a position, that's it. In this position, see, here is coming to the conclusion. During the first half cycle, the rotor just tilt away in anti-clockwise direction. During the next half cycle, the rotor moves in clockwise direction with respect to stator. See, this continuous and rapid rotation of the stator poles, and the rotor gets subject to the quickly reversing the torque. Due to the inertia of the rotor, it will not respond to such torques and will remain stationary. Therefore, synchronous motor is not a self-starting motor. Then, how to start a synchronous motor? As I said that the synchronous motor is not a self-starting motor. Then how can we start? How can we start? Suppose the rotor is rotated by some external means at a speed very near to the equals of the synchronous speed. When the rotor is excited to produce its poles, at a certain instant of now, the stator and the rotor, unlike poles, face each other. Okay, unlike poles face each other, such that the magnetic axes are very near. Unlike the force of attraction between two poles, both of them into the magnetic locking condition. Once the magnetic lock is established, the rotor continuously experiences a unidirectional torque in the direction of the rotating magnetic field RMF, as the rotor rotates at a synchronous speed, and this will be set to a synchronism with RMF. I will be discussing about the RMF, don't worry. So what do you mean by RMF? Rotating magnetic field. The magnetic field having the moving polarities. Because of the two reasons, the RMF is produced. 1. The winding of the stator are equally displaced, and this equally displaced at an angle of 120. See, and this one and this one, this phase and this phase are 120 degrees apart, and this one and this one, these two parts are 120 degrees apart, and this winding 120 degrees apart. Because of these reasons, the windings of the stator will be equally displaced each other. In this in this equally distributed, so the RMF induces on windings. The rotating magnetic field will be induced on the windings. Okay. The coming to the second reason, the magnitude of three phases are same. The magnitude of the three phases are same. Means equally distributed. The current in all the three phases and windings are equally distributed. Then also then RMF is induced on the stator. Okay. Coming to RMS, mainly the rotating magnetic field mainly depends upon synchronous speed. Because of synchronous speed, ns is a synchronous speed. Ns is equal to 120 f by p. Note down this point, very important. Ns is equal to 120 f by p. Here f means frequency, p means number of poles, ns means synchronous speed. Ns is equal to 120 f by p. Also, the synchronous speed of the rotating magnetic field depends upon the frequency of the supply. That is, if you vary the frequency, then the speed of the RM rotating magnetic field also changes. Now I am talking about the torque, the force which try to rotate in a circular direction. Torque is nothing but the force which rotates in the circular direction. Because of the inertia, it is not rotating fully. The rotor is not rotating fully because of inertia. The rotor, as I said before the class, earlier in the class, the rotor just only tilt, means some position will be changed, not completely, in anti-clockwise direction as a clockwise direction. As positive cycle, as the positive side of cycle and the negative half cycle. During the first half cycle, the repulsion force is created during the first half cycle, and during the negative half cycle, poles are changed in the stator. Poles are changed in the stator. Now, what happens in the stator now? The poles are changed in stator. The opposite poles are facing each other. The opposite poles will be facing each other. So, they try to drag the rotor in the rotating magnetic field. So, it is not completely rotate here also. So, mainly, synchronous motor is not self-starting motor because of two reasons. One is motor overload, two is low supply voltage. And coming to the applications, now where do we use synchronous motors? Mainly in, so coming to the applications, sorry for the distance. Coming to the applications, depending on these four, mainly the applications will be concentrated. One is power factor correction, constant speed applications, improving the voltage regulation, and also the frequency changer. What do you mean by power factor correction? Correction means the power excited synchronous machines always work on the synchronous condensers. Synchronous condensers are used for the improvement of power factor of industrial loads when having the lagging power factors. As I said, the synchronous condensers. What do you mean by synchronous condensers? A synchronous motor operating on the no load with over excitation and also supplying the leading reactive power, then it is called a synchronous condenser. It will be used for the improving the power factor of the industrial plants, mainly used for the lagging loads. Okay, and coming to the constant speed applications, synchronous motors providing the constant speed at a very high speed efficiency. So they can be used for the constant speed applications such as centrifugal pumps, blowers, the line shafts, motor generator sets, synchronous clocks, and also the ammonia and air compressors, the textile mills, paper mills, and the cement mills. And these are the synchronous, and these are the constant speed applications, and also the improving the voltage regulation. Improving the voltage regulation for a long transmission lines. Okay, synchronous motor with field regulator can be used to control the voltage at the end of the long transmission lines by varying the excitation. And what do you mean the frequency changer? Basically, the synchronous motors can be used to drive another alternator to generate a supply at a different frequency. Due to this constant speed nature, in this case also we can use frequency changer. Okay, so last, before concluding the topic, we'll be talking about the advantages. Advantages means the speed is constant and independent of the load. One is the point to be noted, and also an over excited synchronous motors works on synchronous condensations when connected in parallel with the load will be having lagging power factor, and also it will improve the power factor of the combined load. The power factor can be controlled easily in these motors. Okay, the motor can work at lagging and leading power factors also. Coming to the disadvantages of the synchronous motors, it is a not self-starting machine, and it also requires separate DC excitation system. Initial cost is very high. Okay, and also what? Yes, if a motor is overloaded, it may fall out of synchronism and it will just stop rotating, and it cannot be used for the variable speed jobs. And also it is tendency to hurt. Yes. Okay, thank you for listening my class. Please subscribe for more videos. I will be doing Rrb JE also, and also SSC JE classes based on the electrical engineering.